Alright, so happy morning to everyone. It's getting on for noon, and, well, um, just going to talk about this video that showed the skipping encoder. We'll talk about why the encoders, it's actually really not an encoder, it's a switch, but why they miss steps. But anyway, so a lot of people came through with this video and sent it to me, and it's, other than full of the sort of muppety hyperbolic nonsense. It's stuff like this. It's this nutter Paula White, talking about angels blessing the knob so that it might work. Well, the knob really doesn't work. And I think that's the issue behind why he is taking extraordinary steps like abusing copyright to get them down. Because the videos at this point, the videos all over the bloody place. I've been sent at least 15 links to the same video. This is stress in effect at work. But anyway, why doesn't it work? So, in the name of science, I'm going to attach a bloody drill to the thing, which is, we don't test these things this way. I just want to point that out. This isn't you don't test things like this. This is not a proper test. But I've had a few people ask me to just go ahead and do it. So this is the way that I have a logic analyzer connected to the radio. I have one on the RX line, so this is the receive line from the main to the sub micro, and the TX is transmitting from the sub to the main. Up is connected to the up line, which is right here at this point. So we will be able to see if the control doesn't respond to input, because there will be a period of basically silence where it's when it does a skip. If it's the control, you will actually see it. But other than that, it's fairly straightforward. RX and TX lines are pins 1 and 3 on this connector. It's just a little cable that goes down from the front panel to the main board. And we can grab some data and look at the bus states right now, which the buses are all high. They're idle. There's no data going back and forth because there's nothing happening. The radio is on and not doing anything. So if I go ahead and click the thing clockwise once to the right, which would mean up, you could see that the up control, that data line is pulled down. So this is basically, supposed to be a edge-triggered thing. So on a negative edge, which would be the control pulsing that line to ground, send D, which on this is actually means go up one step, and then you can see the radio responds to the front panel with a new set of commands to redraw the display. And on this radio, it just is the SR955 HP. That is all that's written on the display. The other data is for the meter and the frequency display and so on and so forth. Things like the parameters like the color of the display and so on. That said, that's pretty much it. If we go the other direction, which would be down, and I go one click to the left anti-clockwise, the up line doesn't change. And that's because I'm not attached to the down line, I'm attached to the up line. So this doesn't change. Now we can see that there's actually a U, which means go up, or rather down. It's backwards. D is up and U is down. I didn't write the code, they did. Tell them about it. It's strange, but it's just how they wrote it. So if we do something else, like say turn on the noise blanker, just turn on the noise blanker, and again the up line doesn't change, and it sends a command of 0xF4. It's a non-printable character. It's just just a byte 0xF4, and the radio responds with, again, another big packet to draw the display, which in this case says NB, some spaces, and on. That's basically it. It's a not so complicated protocol. So now, what happens when I go ahead and get my drill and start capturing data, and go ahead and put the drill into it, and slowly speed up the drill, and then stop. And go ahead and take a peek at this. So that's the drill speeding up, and then getting to full speed, and then me stopping the drill. Now, you see it's not missing any pulses here. So you see in the beginning, we have a negative edge, command, response, negative edge, command, response, so on and so forth. So you can see that for every negative edge, there's a command transmitted to the radio. Up until you get to a certain point where it simply can't do it anymore. So it's just starts going too fast, and it starts missing. That's the example here. So the control registered that it was rotated up one, but it was no command transmitted. And again here, and again here. So that's the control. The control's functioning. You can see that here. The control's working. Because every time the control clicks, it pulls the line down, and that's when you see these little dips. That's every time the control clicks. And this is every time the microcontroller registers said click, but it doesn't. And that's down to how they architected the system. You can see it just starts skipping quite badly until it just stops. It's going too fast for it to manage. And it just gets erratic. And this is why it gives the illusion when the drill's running on it that it's working, because it is getting some of these pulses. It's just not getting all of them. So it's just is what it is. The microcontroller is just simply not able to keep up. Now, why is that? So we can look at the architecture of the system, and we can, and looking, of course, at the capture data, and we can make one determination. The first determination that we can make is that the up and the down lines are connected to external interrupt 0 and external interrupt 1, but they're not using the interrupts. If they were using these interrupts in the software, then the skipping that you're seeing here actually wouldn't happen. We are not rotating the control fast enough to overcome an interrupt running on a 19 some odd megahertz microcontroller. We would have to spin the control a lot faster to basically prevent it from triggering interrupts. It may still miss at high rates of speed because it would be inside of the ISR interrupt service routine for the interrupt, and simply unable to respond because if you're in an interrupt, you can't trigger it again. So you will hit that problem, but you're going to hit that problem going way faster than this. So that said, we know these interrupts are not used, and that's just the way they did that. I know why they did that. They are, however, using the interrupt for the UART, and that's exhibited by the fact that the radio always seems to respond to the display packets. So it is always receiving the serial data, and they do that because as it's sending. Okay, so if we look at one of these packets that's being sent, it's basically 0xFE, which is hey, I'm going to start sending you something. Pay attention. Essentially, we'll do that in serial comms to say, hey, I'm getting ready to send you something. And at that point, then it starts the packet. And at the end of the packet, there's going to be a check byte, and this is going to be the check byte right here. So every one of these packets has a check byte. It's 8-bit modulo and so on and so forth. But the thing is, it always gets the packet. So that means this interrupt is actually utilized. And these 8051s, I think they only have a 1 byte buffer or something to that effect. So it basically has to get the byte, trigger the interrupt, and then the code within the controller, microcontroller, has to then copy that byte to some, into its RAM, into probably an array or something, and then grab the next byte. Because as the bytes are coming in, of course, it's triggering interrupt, and I'm sure that they're just storing in a buffer. And when they have a complete packet, at some point, probably periodically, it goes through the buffer and it pulls out the packets, basically looking for the starts and the check bit and saying, okay, I have one, and then processing it. But that means you sacrifice this. I would have done this a little differently, personally, but it's how they did it, and it's their system, and they can do what they want. Just it's not up to us. Now, it's possible that these things can be reprogrammed. I don't have the tool chain for these. These are some odd. These microcontrollers are odd, probably Shenzhen market specials. I don't have a tool chain. I did find the data sheets for some of these, and of course there's no English translations of them, so it would be quite difficult to work out what they're doing. I'd have to basically use an 8051 that I would have access to and develop something, and then see if I can't maybe get it to work with their tool. It's possible, but it's probably something that I wouldn't be able to do without knowing a little bit more about the system. But that said, that is why these things skip. You're not going to put a knob on it. You're not going to change the control. Unless the control's bad. Like in this case of this control, there's nothing wrong with this control. It's working just fine. But yeah, you're not going to do it. It's not going to work. And I think that was what was in this video. I saw the video myself, and you could clearly hear 12 clicks, and you saw it move like only 6 or 7 channels, and that was because it encountered the situation where the control was flicked. And I can do that. I can flick the control. So if I go ahead and flick it, like with my hands, you could see that I flicked the control, and it only moved once. So the control worked. The microcontroller just simply couldn't. It's just not. It's probably polling the pins. Polling, doing a scan against the inputs, so on and so forth. Who knows what they're doing, but they're doing some form of polling, probably in the main loop. And hey, what's the stat? What is the pin's level? Is the pin a 0 or 1? Okay, it's a 0. That means somebody spun the control. Send the command. That sort of thing. This isn't a fixable problem with hardware. This is literally this must be fixed within the code. It's just how they're using the interrupts and how the system was architected. And that's all there is to it. This is essentially a Stryker's ODM problem. So, hey, sorry to rain on the parade, but it is what it is. Feel free to repeat the results. Go ahead, get your logic analyzer connected to the data lines and the upline, and see for yourself. Don't take my word for it. And don't attach drills to your radio. You're either going to get hurt or you're going to break the bloody control. That all that illustrates is that you can spin it really fast and it will appear to work, but in reality, it's really missing a great deal of steps. Anyway, so cheers, guys. Catch you next time.